Okay, everyone, I walked you through some of the problems in the class and I tried to go step by step and then solve it as if I'm you and taking the test, but it took a long time and I couldn't finish all the things that I wanted to talk about. So I'm going to talk about briefly about everything so you have all the solutions at the same place. So to write the chemical formulas for ionic compounds, you write the name of, the cation, the name of the anion, and then you balance the charges. For instance, lithium is Li plus, phosphate is PO4 3 minus, and then here you have like minus 3. So you should have like 3 plus 1 in order to have basically a neutral compound or without any charge. And you do this for all the others as well. For instance, for aluminum oxide, you should first find the lowest common denominator, which is 6, and then in order to have like 6 negative charges, you should have 3 of oxygen and 2 of aluminum. It's as if you write this, as if you put this charge here, this charge here. But be careful because sometimes they may cancel out. For instance, for MgO, they weren't 1. They were like 2, but they, 2 plus, 2 minus. So be careful. But as a rule of thumb, especially if the numbers are not the same, you just switch its numbers. Which statement is not correct? We talked about this in the class, the definition of formula mass, that the formula mass of a compound is the sum of atomic masses of all the atoms in the chemical formula. The other ones are correct and I encourage you to read them for your. What is the formula mass of this? To find the formula masses, you know that, for instance, for Mn2O3, you say 2 Mn2 multiply, you write 2 multiply by Mn plus 3 multiply by O. And then you go to your periodic table, read these numbers which are listed below each element, and then do these calculations. And then here you have you want to see which one of these is heaviest from these elements and which one is an ionic compound. We talked about this. These ones, don't have a metal and they don't have ammonium, so they are not ionic compounds. So one of these two are ionic compounds. And you want to see between these, which one is the heaviest. So your answer is between C and D. So for these ones, you calculate how many gram of the compound equals 10 mole of that, and then with molar mass, you convert them to mass. And then you compare these numbers to see which one is heaviest, or just calculations and find the answer. So which compound name is correct? For calcium, you won't write 2 because it has a fixed charge. Calcium, as you remember, has charge of positive 2 always. So we won't write it because this is fixed. Potassium nitrite is wrong, it's nitrate. Iron, you should specify how many charges it has. So this one is the only correct one. As you can see, it doesn't have a metal, but it still is ionic because it has ammonium. We have 10 grams of each of the following compounds. Which of them consists of the least grams of oxygen? So you say how many grams of oxygen equals 10 grams of your compound. You convert gram to mole by molar mass. With the chemical formula, convert number of moles, and then with molar mass, convert to gram of oxygen. And you remember, for instance, for CuClO3, we say 1 mole of CuClO3 has 1 mole of Cu, 1 mole of Cl, 3 moles of oxygen. And then if you have for instance, something in parentheses, for instance, if you have for instance here, if you have parentheses, you multiply anything in parentheses by the subscript to find the number. So if you have inside the parentheses 3, outside 2, you have 6 moles, and then we encounter Sort option 1, option 2, option 3, option 4 from smallest to greatest value, basically smallest to greatest to largest number. Mass of Cl in 15 gram of compound. And then you know how to name acids. And if you have any questions, come to my office hours or just like, email me, ask me, or like study your book. So again, you have mass of the compound you want to convert to mass of constituent element. You say how many gram of your element equals 15 gram of your compound. With molar mass, you convert to moles with chemical formula, mole to mole, molar mass, mole to gram. And then Professor Stelk was writing these conversion factor as this. You're welcome to use that, whichever is more comfortable for you. And then you find your answers, and then you compare them to see would be number D. Basically is your right answer. And then here I wrote the numbers. You see the smallest, you see the greatest. So basically your answer should look like this. And then in between, option 4, option 2 is smaller than option 4. So which sample contains the most number of atoms? So you say how many number of cobalt atoms equals 1 gram of cobalt. And then with molar mass, you convert those to mole. With Avogadro's number, you convert to number of atoms. And then here, because these ratios are all the same, you can just compare these numbers. When you have a ratio, when the denominator is smallest, you have the larger number here. So basically carbon, 1 gram of carbon contains the most number of atoms. And then imagine you went to grocery and then you have 3 bags. In one, you want to put watermelon. It's extremely heavy compared to other fruits. So maybe you can fit 1. If you have apples, maybe you can fit 10. If you have blueberries, maybe you can fit 100 or like 200. So you see, when each individual weighs less, you will be having more of that. So this is kind of like an analogy to atoms and molecules in general. Fluoride is often added to water as sodium fluoride. We went through this example in the class. You want to find how many gram of fluoride is in 100 gram of NaF. So if you refer to fluoride, we call it F minus. If you're saying fluorine, it would be F. So we convert gram of NaF to mole, mole to mole, mole to gram. So this is this routine for all of our questions. And then you find the answer. So basically in 100 gram of NaF, you have like 45 gram of Na. So mass percent would be like 45%. And then here you want to find gram of NaF in 1500 liter, and then you are given 1 milligram F to liter. So you just write this, you don't do anything, and then these two cancel out. So you get rid of liter, don't worry about it. You convert milligram to gram, gram to mole. From now on, it's just kind of what you were doing. Mole to mole, mole to gram. And then when you find this, you find that it would be like 3.3 gram. Which statement is not correct? The molecular formula of sulfur hexafluoride is SF6. That is correct. HCl is an ionic compound. It has H, is an acid. It doesn't have metal or ammonium, so it's an acid. And then here, dihydrogen monoxide is the other name of water. That is correct because that dihydrogen monoxide. And then gold 4 oxide has the chemical formula of AuO2. I just wrote that, so AuO2. If you are given this, you know that O has charge of -2. And then you have 2 of that, so you have total charge of -4. So it should be like +4 here. Which statement is not correct? All of these statements are correct, and I refer you to the book to study and then see why they are correct. But here, just as the weight of 1,000 nails is constant for different types of nails. So you can, even if you don't know chemistry, you know that you can have a nail really small and a nail really big. So when the weight of these two is different, if you multiply them by 12, still their weight would be different. So their weight changes if depending on what size you have. So with the same rationale, the mass of 1 mole of atoms changes for different atoms. That's why in your periodic table you have different number for hydrogen and carbon. If these numbers were the same, you wouldn't need to go look for these numbers. We are told that 3.24 gram sample of titanium reacts with oxygen and forms 5.40 gram of the metal oxide. So I just realized here that when I was solving the problem here, I wrote titanium oxide. So this one has an error in it. So this is not related to solving this problem, just something that I typed wrong here. So you write titanium and oxide. And then in this problem, you see that the chemical formula, or like rather the empirical formula, which is type of chemical formula, is TiO2. So the charge of oxygen is 2 minus, and then you have 2 of oxygen. So the total charge is minus 4. So you should have like titanium plus 4. So the compound would be neutral. So this one would be titanium 4 oxide. So just without even reading the problem, you should read the problem, but when you go through the problem, you see that you are not being given molar mass of the compound. You are given, like you said, you were told that this much of titanium reacts with oxygen, gives you this much of metal oxide. And that's it. And then you are given the periodic table of elements. So you cannot find molecular formula. For that, you should have molar mass of your compound. So just reading the problem statement, you know that this one is wrong. But regardless, because all your reactants are converted to products, and this is where chapter 7 comes to the play, although it's not in your exam, but now when I say reactant and products, you know what I'm talking about. And then you know potentially how to write these reactions. So since all of them are converted to metal oxide, you can just deduct 5.40 by 3.25 and then find the grams of oxygen. So number B is correct. Number A is also correct. So number D. And then if you want to find the moles, you just use the molar mass of each compound and then find the moles. So number C is correct. And then to find the empirical formula, you write these numbers. So you have like this much of titanium, this much of oxygen, and divide them by the smallest number, and then you find TiO 1.99. So you remember these numbers should be whole numbers, so you round them and then you find the empirical formulas. Not correct. Which of the following consists of only metals? So we see that hydrogen is non-metal, although sodium, lithium, sodium, potassium are metal, but this one is non-metal. So this one, it has things other than only metals. Beryllium, magnesium, calcium are metals, but silicon is a metalloid. And germanium, tellurium, boron also metalloid. Vanadium is a metal. Aluminum, copper, zinc, mercury, they are all metals. And then as you remember, metalloids are elements that are like between metals and non-metals in periodic table. So they have like kind of, their properties is intermediate between metals and non-metals. And then I encourage you go to a periodic table, kind of know the location of metals and non-metals so you won't be having problems for your exam. And then sort the following elements based on their atomic mass. This is easy. You go just to periodic table, read these numbers, and then sort these numbers. So I just did those here. So this just like paying attention to the numbers and then sorting. Which of the following answers contain all metals with invariant charges? Remember, just remember variant, basically, okay, with invariant charges. So you had like group 1A, group 2A, basically alkaline earth, and then aluminum, zinc, silver. So cesium, I'm just getting tired. Cesium, calcium, silver. So these are like, group 1 and 2. Basically, cesium is group 1, this is group 2, silver, zinc. All of these are like have invariant charges, but lead has, variant charges. And then you can refer to tables 5.4 and 5.5. Copper has variant charges, zinc, sodium, strontium, barium has fixed charges. Tin and mercury has variant charges, zinc, silver has, fixed charges, invariant charges, but lead has also variant charges. Silver, aluminum, magnesium, cesium, lithium. Number D is your answer. Which statement is correct? All transition metals. So in general, in your life, anytime that you're taking a test and it says all transition metals, all people, all, or like any material, or like everything without exception. Usually when you see these extreme phrases, those are wrong. So this is not 100% of the time, but most of the time that is the case. All transition metals form more than one type of ion. No, we just said Z and Ag. Those are exceptions. So this is wrong. Cr, Fe, Zn, Zr are examples of transition metals that form more than one type of ion. No, Zn has, fixed charge. Ionic compounds, for sure, this is again extreme, consists of a metal, non-metal. What about ammonium? No, they are usually consist of metal and non-metal. We categorize chemical formulas into 3 types: empirical, molecular, and structural. This is correct. Which statement is not correct? Even though atoms combine in whole number ratios, their mass ratios are not necessarily whole numbers. This is true. The ratio of hydrogen to oxygen in a mixture is variant. So remember, there is a difference between mixture and compound. In a mixture, you can have like variant, ratios of number of atoms. But in the mixture, this ratio of, for instance, hydrogen, oxygen in the compound is fixed, but in a mixture it can be variant. And I encourage you to go study chapter or section 5.2 for more information. For instance, water is H2O. We don't call H2O2 water. We don't call H3O water, just H2O. Molecular elements normally exist in nature with single atoms as their basic unit. No, they do not usually occur as like just single element. So refer to section 5.4 to study more. Which of the following is an ionic compound? NO is molecular, CCl4 is molecular, non-metal plus non-metal. Au is a metal, it's not a compound. So it's not a compound to be ionic or not, And NH4Cl4, it has anion, basically ClO4 minus, and cation. So this is an ionic compound. Which of these elements exist as diatomic molecules? So these are your diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So don't confuse this. Barium, bismuth, beryllium. Barium and beryllium are metals. Bismuth is one of your... Actually, bismuth is also metal. So the other ones all are metals. Yeah, just different groups. Which formula represents the greatest number of greatest number of atoms? So it's the same as finding moles when you want to count number of atoms. You have like, if, in one, basically if you have like one of your units, so for ionic compound, each of them are like one unit, and for like molecular compound, we just call them one molecule. So in each of these chemical formula, when you want to count number of atoms, you have like 1 aluminum, 2 multiplied by 3, 6 carbon, 3 multiplied by 3, 9 hydrogen, 2 multiplied by 3, 6 oxygen. And then you do the same here, like 2 aluminum, 3 multiplied by 2 chromium, 7 multiplied by 3 oxygen, and so on and so forth. You can just like, calculate these numbers, add these, and then see which one is like greatest, which is like in this case 29. And then here, which of the following is not an acid? So all of these have hydrogen, they are acid, and then this one has metal, basically cation, and anion, so it's an ionic compound, not an acid. And then I name them here too for your reference. Just ask me if you have any question. Which of the following samples has the smallest mass? You say how many gram of CF4, and then you should name the carbon. You know that when it's at the beginning, naming molecular compounds, at the beginning when it's mono, we don't write it. Tetrafluoride, base name of the non-metal plus ide. Magnesium fluoride, magnesium, you write F2, and then it would have been Mg2 plus F minus. You should have 2 of fluorine for this compound to be without any charge. Carbon D sulfide, you remember mono, di, tri, so carbon disulfide. Anyway, so after writing these, you say how many gram of CF4 equals this much of mole. With molar mass, you convert to gram. So this is pretty straightforward. And then you know that for molar mass, you say count the number of atoms multiplied by that element plus number of fluorine multiplied by F. These 3, and then calculate the grams, you realize that this one has the smallest. And then you kind of have your answer makes sense because you have milli 10 to the power of minus 3. And then when you do these calculations, it would probably be the smallest. But it depends on your number and then your structure here too. A mothball is composed of naphthalene. We went through this example in the class and has a mass of 2.32. How many naphthalene molecules does it contain? You first, calculate molar mass, and you know how to do it. If you have any issues, come to me and ask me. And then you say how many molecules equal this much of gram. With molar mass, you convert gram to mole, and then with Avogadro's number, you convert mole to number of molecules. And then you find this answer to be A. Which sample has the most number of molecules? So first, calculate formula mass for each of these, and then you know how to do this, right? 2 hydrogen, 1 oxygen, 6 carbon, 12 hydrogen, 6 oxygen, and so on and so forth. And then you say how many hydrogen molecules equals 10 gram of hydrogen. With molar mass, you convert to mole. With Avogadro's number, convert to number of molecules. And then here, since you just want to compare, you can just write these ratios and then compare these. You want to see which one is this one. Number B is the biggest, but so you see that you just calculate the whole thing too. So that can save you time if you just compare the ratios, because the other part, this part, is the same for all of them. What is the mass percent composition of hydrogen in C2H8N2? I asked you in the exam what is mass percent composition, so you should know this formula really well. Mass percent composition of element X is mass of element X in 1 mole of the compound divided by mass of 1 mole of compound multiplied by 100%. So when you write that for hydrogen, you realize that in 1 mole of C2H8N2, we have 8 moles of hydrogen. So 8 multiplied by molar mass of hydrogen divided by molar mass of your compound multiplied by 100%. When you do this math, you find your answer being 13.44%. So this was really quick overview of your quiz 3. So if you know all these concepts, and if you basically go through the study guide and also study the quiz and can solve the quiz yourself, you're in pretty good shape for the exam. And I can kind of guarantee that if you understood everything that I just said right now really well, and then go study the study guide and know all the answers to that, I almost can guarantee that you can get an A. So hopefully you can study these materials tomorrow, because now it's so late, 11:55 p.m. So ask me any questions that you have, and hopefully you will watch this video.